What's up guys, and welcome to today's video. So in today's video I'm going to be showing you guys how we can interact with a smart contract that is already deployed, how we can make deposits and withdrawals from this smart contract, and also how we can attack this smart contract using Reentrancy and Foundry. So guys, if you watch my last video, I showed you guys how we can use Slither to detect vulnerable smart contracts, you get, and we're able to detect a smart contract that's actually vulnerable to reentrancy attack. So in this video we are going to deploy a smart contract that's going to exploit that smart contract that's vulnerable, and we're going to see if we can actually drain all the money in this smart contract. Okay, so guys, so this is a detailed article of what we're going to do. If you have any question, let me know in the comment section. Contract we're going to deploy is a bank contract. It receives Ethereum as deposit, and whoever sends the Ethereum can actually withdraw the Ethereum. So it works like a typical bank, just that it has no third party. It's just a smart contract and nobody's controlling it. It doesn't need any KYC. All you just have to do is to call the smart contract and send in your deposit, and whenever you need your money, you call in the smart contract and request a withdrawal, and it's going to send it to you. This smart contract is vulnerable. We're going to exploit that vulnerability, and also we are also going to secure this smart contract and try and see if we can exploit it again using reentrancy, and it's supposed to fail, right? So this is the smart contract. This is the attack bank smart contracts that we're going to deploy to the Ethereum testnet and see if we can actually attack the already deployed smart contract and drain its funds. So just go ahead and start the process. If you have any question, let me know in the comment section. This is the deployment script. This is the code we're going to write to Foundry. So we're going to make deposit to the bank, and we're also going to withdraw just to make sure this bank smart contract works, right? Then we're also going to attack it. So guys, we're going to start afresh. So we're just going to go to a new folder. Right, so guys, we are starting afresh from the beginning. I'm just going to show you guys step by step the process, right? So this is a new folder, and we are going to open this folder on a Visual Studio Code. Okay, so let's just copy this address and let's go to our command prompt. So let's change the directory to this address. So now we are inside this folder. So let's open our Visual Studio Code. I already have a video on how you can deploy a smart contract. I already had a video how you can deploy a smart contract using Foundry. So there I explained everything to you guys. So just go ahead and watch the video. So let's go. So this is the video how we can deploy a smart contract, but we're going to do the same thing again. So let's just continue. So I've opened our terminal in Visual Studio Code. So because this is Windows and we're using PowerShell, so we're just going to switch this. Let me close this. We're going to switch this to WSL. Perfect. So the first thing we want to do now, we want to create a Foundry project. So let's just write Forge in it. As you can see, it's creating a Foundry project for us. It's going to create a test file and a source file. Okay, so we'll just allow it some time. So guys, once that is done, as you can see, it came with it gave us default script. We're just going to delete all of this because we're going to be uploading our own script. So let's go back to this. So the first thing we're going to do, we have to deploy our bank smart contract and actually interact with this bank smart contract. So we're going to deploy this bank smart contract KONVATI.sol. So let's just do that right away. If you have any question, let me know in the comment section. So this is the smart contract. As you can see, it accepts deposit and it also withdraw deposit, but this smart contract is vulnerable to reentrancy attack because of this. So let's try and see whether we can exploit this smart contract. So let's go to the deployment script. Let's copy the deployment script. let's go ahead and deploy our bank and let's test it, right? So how do we deploy this bank now? So we need an RPC node. So let's just create an environment, new file, just .env. And we're going to deploy our KONVATI bank smart contract and we're going to interact with it. So first and foremost, let's deploy this smart contract using Foundry. So this is the code we're going to put on Foundry, and we're going to replace this with our RPC URL, and we're going to add our private key. Let's just go back to my Visual Studio Code. So I'm just going to copy and paste this code, and I'm going to hit enter. So it's compiling. As you can see, it's setting up the EVM. Okay. So we are deploying the smart contract code. That's very good. So the error was this. There was a typo error here. There was a typo error from this. So I'm going to correct this. So this was the typo error. That's how I've been getting so many errors. So now, guys, we have our bank. This bank contract is live. You can copy this address and you can check this transaction hash on the supplier testnet. So we're just going to copy this contract address because we're going to be interacting with this contract. Let's just go to environment. Let's just create a new KONVATI bank. So this is what we're going to do right now. We're going to check this smart contract if it's actually live. If you have any question, let me know in the comment section. This smart contract is live. Okay, as you can see, it was deployed 1 minute ago, and this is the transaction hash. So as you can see, transaction hash 6D9. As you can see, it's actually it's live. So we're going to interact with this smart contract, this KONVATI bank. As you can see, this KONVATI bank, it's a simple bank contract that accept deposit and withdraw. But this bank contract is vulnerable. But let's just let's try and send money to this contract, right? So let's come here. As you can see, we have some funds here, right? We have some Ethereum here. So let's try and see if we can actually send money to this smart contract. So let's get the smart contract code. So this is the code. Let's just copy this address and let's come here. Let's paste this address. As you can see, guys, it's not letting me send. As you can see, guys, it's not letting me. As you can see, guys, it's not letting me send money to this smart contract because the way it's designed, right? You can't send money to it. You can only deposit and you can withdraw. So how can we interact with this smart contract? How can we actually deposit this smart contract? Okay, so let's do that right away. So let's try and make a deposit of 0.001 ether, right? So how do we do that? Okay, so we're just going to copy this line of code and we're going to go to our Foundry and we're just going to paste this line of code. We're going to change this with the smart contract address. If you have any question, let me know in the comment section. We're going to send 0.001 ether to this bank, okay? For the purpose of this video, let's go to Etherscan. Let's copy the contract address, right? And let's paste it here. Perfect. So let's hit enter. We've successfully deposited money into this smart contract. So if you come here now, as you can see, the Ethereum balance is 0. So let's just refresh this, okay? So because of time constraints, I'll have to end the video here, but I'm going to do a second video. I'm going to post the second video. You're either going to see the second video pop up, or I'm going to post it in the description below or in the comment section. And also, if you want to contact me, head over to konvati.com/withdraw. You're going to be directed to me, or just go to the website konvati.com/session and book a session with me. Just watch the second video, guys. As you can see, we were able to successfully carry out this Reentrancy attack. Alright, guys, if you like this video, give this video a thumbs up. If you don't like this video, give this video a thumbs down, but let me know the reason in the comment section below. See you guys in my next video.